Here in session 107, we'll be solving linear inequalities, but before we do, let's review some of the properties or qualities of equalities and see which one of those apply also to inequalities. If you remember from basic equations, which are equalities, in algebra, whatever you do to one side of the equation, you have to do it to the other. So if you multiply, divide, add, or subtract any number from the left side of the equation, you need to do the same thing to the right side of the equation, and you have created an equivalent equation. The exception there being either multiplying or dividing by 0. Now, as far as inequalities go, let's see what happens. Let's start off with addition. Our first inequality here states that 4 is greater than 1. Well, if we decided to add a 10 to both sides of this inequality, 10 plus 4 would be 14. 10 plus 11 is 11. Would 14 be greater than 11? Yes. If we added 100 to the left side, 100 plus 4 is 104, and then added 100 to the right side, 100 plus 1 is 101. Is 104 greater than 101? Yes. So we can see that for addition, it doesn't matter what number we add to both sides. We could even add a negative number to both sides. What if I were to add a negative 3 to both sides? Well, 4 plus a negative 3 would be a positive 1. 1 plus a negative 3 would be a negative 2. Positive 1 would be greater than negative 2. So whether we add a positive number or add a negative number, and remember adding a negative number is the same thing as subtracting. So to rephrase this, it doesn't matter whether we add or subtract a positive or a negative number from both sides of an inequality, the inequality will still hold true. The direction will still remain the same. What about if we multiplied both sides of an inequality by the same number? Well, let's multiply both by 11. Well, what's 11 times 4? 44. 11 times 1 is 11. Is 44 still greater than 11? Yes. What if we multiplied by 1? 4 times 1 is 4. 1 times 1 is 1. 4 is still greater than 1. What if we divide by a number? Let's divide by 4. Let's divide both sides by 4. 4 divided by 4 is 1. 1 divided by 4 is 0.25. Is 1 greater than 0.25? Yes. And you could go ahead and show that for any numbers that you choose. Positive numbers, that when you multiply both sides of an inequality or you divide both sides of an inequality by a positive number, you have not changed the direction or the truth of the inequality. But something different happens when you multiply or divide by a negative number. So I'm going to go ahead and write that out over here. Let's go ahead and multiply both sides by a negative 10. Well, 4 times negative 10 is minus 40. And then 1 times negative 10 is negative 10. Is 40 greater than negative 10? No. In fact, just the opposite has happened. 40 is less than negative 10. And this holds true for any negative number that you would multiply both sides by, or any negative number that you would divide both sides by. Whenever you have an inequality and you multiply or divide both sides of the inequality by a negative number, that reverses the direction of the sign. Here the sign originally says greater than. After we've multiplied by a negative, it now reverses and becomes a less than. But for anything else, positive numbers being multiplied and divided, or any number, positive or negative, being added or subtracted on both sides of the inequality, your direction of the inequality remains the same. Okay, that's the 4 operational properties in a nutshell with inequalities. Let's use some of those now to come down here and solve some inequalities. X minus 3 is greater than 7. We're trying to get x all by itself. Well, right now the x has a 3 being subtracted, so to undo that we need to add 3 to both sides. Well, x minus 3 plus 3 greater, I forgot that plus 3 there. X minus 3 plus 3 greater than 7 plus 3. Well, x minus 3 plus 3 is the same thing as just x. I'll write that above it. and 7 plus 3 is 10. This is the solution to this linear inequality. X has to be greater than 10 in order for x minus 3 to be greater than 7. Let's go ahead and stick that 10 in here. 10 minus 3 is 7. Is 7 greater than 7? No. That's why x has to be greater than 10. Anything greater than 10 will create an inequality here of that number minus 3 being greater than 7. Let's take a look at our second example, our second inequality. 2x plus 4 is less than or equal to 6. Once again, we're trying to solve this for x. We're going to subtract 4 from both sides. Well, after we do that, that leaves us 2x on the left side of the inequality. And after we subtract 4 on the right side, 6 minus 4 would be 2. X is still not by itself. We need to divide both sides by 2. Well, after we've done that, 2x divided by 2 will leave us with x on the left side. And 2 divided by 2 will leave us with 1 on the right side. The solution to this inequality is x must be less than or equal to 1. Let's take that 1 and place it back into our inequality and see what we get. 2 times 1 is 2. 2 plus 4 is 6. Is 6 less than or equal to 6? Yes, it is. So 1 is a solution. But anything less than 1 is also a solution. Therefore, the proper way of illustrating or describing that would be x is less than or equal to 1. Let's take a look at one more here. Here we not only have an inequality where we have 3 parts to it. This middle part, x over 3 plus 2, is greater than or equal to minus 2, but less than 10. So we have an extra phrase here now in our inequality statement. But we're also going to have to multiply here to solve for x. So let's start off. Minus 2 and 10 are not fractions. 2 is not a fraction, but x over 3 is. So what do we need to do here to get rid of this 3 that's in the denominator? Well, we could change all of our other numbers here into fractions that had a 3 in the denominator, or we could simply multiply everything here by 3, because if we multiply x over 3 by 3, that'll cancel out the 3's and just leave us with an x. So what we're going to do here is multiply everything in here by 3. So we're going to take the 3 and multiply that by our negative 2, and that's going to be less than or equal to 3 times x over 3 plus 2, and that's going to be less than 3 times 10. Now let's go ahead and calculate some things out here. 3 times minus 2 is minus 6, and that's going to be less than or equal to 3 times x over 3 is the same thing as x. 3 times 2 is 6, so that's going to be x plus 6, and then 3, and that's going to be less than 3 times 10, which is 30. Now we're still needing to get the x by itself. We need to subtract 6 from everything to get the x by itself. So what is a minus 6 minus a 6? Well, it's a negative 12. Our middle term here, x plus 6 minus 6 is x. And that's less than 30 minus 6 is 24. This is our solution. X must be greater than or equal to negative 12 but less than 24 in order for this inequality up here to be true. Well, let's start at minus 12. Let's go ahead and stick in a minus 12 for x. Minus 12 over 3 is minus 4. Minus 4 plus 2 is minus 2. Is minus 2 greater than or equal to minus 2? Yes. And is minus 2 also less than 10? Yes. Let's come over here to the opposite end, 24. Let's put a 24 in here for the x. 24 over x, 24 over 3, x being 24, would be 8. 8 plus 2 is 10. Is 10 greater than or equal to minus 2? Yes. But is 10 less than 10? No, it's not less than 10. That's why we had a less than symbol here. It's not less than or equal to, it's less than 24. So in order for this inequality to be true, x must be less than 24, but must be greater than or equal to negative 12. Review. Adding or subtracting the same number from both sides of an inequality does not change the direction of the inequality. Next, multiplying or dividing both sides of an inequality by a positive number does not change the direction of the inequality. However, multiplying or dividing both sides of an inequality by a negative number does change the direction of the inequality. And that'll finish up session 107.